Hi, and welcome to another lesson where we're doing the number systems for computer systems. So, course 1521, basically. Um, and I wanted to check if I could change the pen into a different color. Okay, I thought I could have a lot of colors, but it's fine. Um, also, I just wanted to say, please do subscribe to the YouTube channel. Also, like and then leave some comments to know if I'm doing well or not. We're also going to be working on some things, so you can leave your answers here in the comment section. I have also a small group that I'm assisting. Obviously, you do have to pay. However, I do also have a bigger group where I'm assisting people, or not assisting people, we assisting each other. However, I won't be assisting in that specific group. You can find the link in the description box that I'm gonna leave the link in there that you can find, right? And then also, a lot of people from my smaller group were asking me to do a compilation of past papers. So I am going to do that, but I just want us to at least have a little bit of an idea with regards to the concepts. So yeah, we're starting with the number systems. All you have to know is that there are four number systems, namely the binary system, the decimal system, the octal system, and then the hexadecimal system. And then we're going to discuss in depth, right? So you have your binary, your decimal, your octal, and then your hexadecimal, right? With your binary, and I've already started. With your binary, it's a base 2 number. So it's a base 2 number. And it's quite obvious with the 2 because when you look at the word bi means 2. Like if you have your bicycles and stuff like that, bi would mean 2. So binary is a set of 2-digit numbers or elements, but namely the numbers, right? And it can be 1 and 0, or you can create proper sets of um, this, right? So that would be your binary number. And every time all these numbers would start from 0 up to the last number or the last base, in this case, 2, right? However, when you get to that base number, you subtract 1. So instead of going 0, 1, 2, you subtract 1 from the 2, meaning you just have 0, 1, 1. 1 is the same as 1, so you just have 0 and 1. Do you understand? So hence why it's a binary number. With the decimal number system, you also start from 0. So I'm just gonna start from 0 all the way up to 9. Like I said, when you get to the last number base, in that case, it would be 10. You subtract 1, leaving you with another 9, and 9 is the same as 9. So you can just write it as is, right? So I just need you to, and another way to think of it, if you write numbers from 0 up to 9, you obviously have 10 numbers if you include 0. And then with the octal is a base 8 number. So if you think of an octa, anything that is oct, you think of a base 8 number. And with that, you'd have up to 7 elements. The hexadecimal is quite different. It has decimals, the decimal number system in it, which would be from 0 and up to 9. And then when you think of numbers that start from 10, 11, 12, 13, 14, and 16, 15, sorry, 15, because it's a hexa, it has to have 6 alphabets. So you'd go A, and up to F, right? If you were to count all of these, you would indeed have 16 elements in the hexadecimal, right? Okay, so in summary, the binary numbers are a set of two numbers or elements, but we would use numbers quite often. The octal numbers are a set of 8 numbers, a decimal numbers is a set of 10 numbers, and then the hexadecimal is a set of 16 elements. So, or you can say 10 numbers and 5 alphabets. So now we're going to learn what happens behind the scenes, right, of the computer. Like I said, in the learning outcomes here, you're going to learn things that happen and how information is being brought back to you, right, from any device. So we're going to firstly convert binary to decimal. So this basically means we're converting what the calculator sees to what you would get, right? Or how the calculator solves to the answer that you would get. So for example, if you have, don't know why I'm drawing in the set. So if you have the numbers 0 and 1, so I wouldn't use that comma. If you have 0 and 1, and to show that you are dealing here with binary numbers, you would show it the subscript 2, and then you're asked to convert it to a decimal. To show that it's a decimal, you would have that little 10 there, right? If you think of it, this, you can't read this as 1. Obviously, in decimal, you know that when you see something as 0, 2, this means 2, right? All in all. However, when you come to binary, where you're dealing with zeros and 1, you read it as 0 and 1 instead of 1 as a whole. Because if you say 1, that means you are referring to this decimal. A 0 is in the binary, so you do have to take note of the 0. Okay, so if you had this and you were asked to convert it to a binary, you look at what you have in binary. So in binary, you're dealing with base 2s, right? And then every time when you're going to something, you start from 0 up to infinity numbers, right? Infinity numbers. So what happens here, because you're going to a decimal, your next step would be to the left, 0, 2 to the power 0 times 1 plus 2 to the power 1 times 0. And I'm taking these, this 1 here that I'm timesing by and the 0 from this. So 2 to the power 1 would be the first, and we know that the first number always is a 0, so that's hence why we have the 2 to the power 0. And because we're dealing with a binary, you're going to have 2 to the power, right? If you were dealing with an octal number, you were going to have 8 to the power 0, right? And then the second number here would be 2 to the power 1 times 0, the 0 that you see here from the question. Solving this, you would have 0 plus 1, and this as your final answer would be 1. Then if you want to represent that you're talking about the base 10 number system, you'd have a little subscript 10 over there. Okay, let's try another one. Say, for example, you had to solve 1, 0 to how a normal person would see it. So the decimal, which is the base 10. So in this case, you would have, your next step would be 2 to the power 0 times 0 plus 2 to the power 1 times 1. This being 2 plus 0, and that is 2. If you want to show that you're dealing with a base 10 number, you'd have a little subscript 10. Let's look at bigger numbers to solve. So I'm going to do 2, and I'm going to give you about 4 to try on your own, which you can post the numbers, your answers, sorry, in decimal form in the comment section. So say you had 1 0 0 1 1 0 1 2, and then you were asked to convert this to a decimal. So in this case, the cheating method would be for you to count how many numbers you have starting from 0 and going that way. So from right to left. So you would have 1, 2, 3, 4, 5, 6, 7. Sorry, starting from 0 would be 0, 1, 2, 3, 4, 5, 6. So that means you can start from here now. 2 to the power 6 times 1 plus 2 to the power 5 times 0. Obviously, once you start mastering this, you're going to want to skip the off state. So where you see 0, can you see that you keep multiplying by 0? That means the computer actually ignores all the zeros, because 0 would mean off state or false, and then 1 would mean on state. So we calculate the ones where we have a 1. However, you don't skip the number pattern, meaning if this was 0 to the 2 to the power 1, this would remain as 2 to the power 2. Whether you skip this or not, this will always remain as 2 to the power 2, basically. And I'm going to show you another way to work this faster. Obviously, you do have to know your 2's table. So 2 to the power 0 is always equal to 1. 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. 2 to the power 5, 32. 2 to the power 6 is 64. 2 to the power 7 is 128. You can go up to 9. I think they wouldn't ask for more than that. So just know your stuff, right? So all in all here, if you do your calculations correctly, you'd have 1 plus 4 plus 8 plus 64. This gives you 5 plus 8 plus 64. This is 69 plus 8, and that's 77. If you want to show that you're dealing with a decimal number, so you would have 77 base 10, right? So that's how it shows. And this is basically your steps. I wanted to show you another way of doing this. So if obviously you know your conversions, like you know what the first one would be, it's always equal to 1 because it's times 1. So 2 to the power 0 times 1 in your head, you'd write 1. You skip this, 2 to the power 2 would be 4. 2 to the power 3 would be 8. And then you skip these 2. And then 2 to the power 6, I think, would be 64. So you can skip all of this step. You can skip this, but to show all your calculations, you can have it. It's just, it becomes hideous, obviously, if you're dealing with bigger binary sets, right? So having to write up to 2 to the power 9 would be obviously a problem. So you just want to skip to this step. Obviously, you're not supposed to use a calculator, so you do have to remember this for all your conversions. So let's try another one. Okay, so let's say you had 0, 1, 1, 0, 1, 0, 0, 1, 2, and you're asked to convert it to a base 10. So for this, you're going to have, so this, it's 2 to the power 0, which is 2, plus, you skip 2 to the power 1, 2 to the power 2, 2 to the power 3 is 8. So 2 to the power 0 should be 1. This is 1. And then, so 0, 1, 2, 3, 4, 5. 2 to the power 5 is more like your 32. 2 to the power 6 is 64, right? So this would be 9 plus 32 plus 64, which is 41 plus 64, which is 105 in the base 10. So you would want to have something like this. So I'm just going to leave you to try some things. You can pause, think, yeah. So try. So 1, 1, sorry, 1, 1, 1, 0, 1, 0, 0, 1, 2, and then number 2, 0, 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0. So you can try those. I'm just gonna give you the answers. So the answer for the first one would be 233 base 10. Then the second one would be 9 base 10. And the third one, 54 base 10. I don't know the other one, 78 base 10. And the last one would be 682 base 10. And all of those are being converted to decimals, right? So in summary, you do have to know your 2 to the powers, where 2 is always your base, and then your base number. So we learned that things are bases and we have powers. So that's basically where the base comes from. So every time you're doing 2 to the power something, you're actually learning, but we are not taught that we actually are converting things to decimal. So it's quite funny, right? So I'm just going to talk about a diagram that's on page 29. If you look at the, I don't know, I think it's the Fausal textbook. I'm not sure the name. So here we're going to be learning how to convert a decimal to a binary. However, it's you basically converting anything, so a decimal to anything. How the most important thing that you have to remember is that whenever you're going from any number system, so any number system, be it a 2, the 8, or the 16, right? If you are converting it to a decimal, to what humans can see or read, if you converting it to a decimal or a base 10 number, you always use the 2 to the power 0, or you can use 8 to the power 0, or the 16 to the power 0. However, if you're going in reverse, you have to use this table that I'm talking about, right? Yeah, so yeah, you quite have to know it. I think rather than that, let me just teach how to convert another thing to the decimal system. So just give me a few minutes. Okay, so let's talk about converting an octal. I keep spelling it wrong, I don't know. An octal or the base 8 to a decimal. What do you think we should do? So base 10, right? So if you have maybe 8 to 1, let me use examples that I have because I'm hesitating to calculate and make the video longer than it's supposed to be. Um, I need a lot of examples of octal in my book. So we're just gonna work on it. I was supposed to type them, not sure where they are. Okay, so let's say you have for number one, let's say you have 1, 2, 3 as your octal and you're asked to convert it to a base 10. Remember, whenever you're going to a base 10, you think of the powers, right? So the power that you have to do everything quick, basically. So what you do is you look at how many numbers you have. In this case, you have 3 numbers. You can do the thing that we were doing where you can count. So 0, 1, 2, that means you have to have up to 8 to the power 2. 8 to the power 2 times 1 plus 8 to the power 1 times 2 plus 8 to the power 0 times 3. And that basically is 8 to the power 2. I think it's 64. I'm not sure. 8 to the power 1 times 2 is 16 plus 3. So that's 1 times 3. Working this, you'd have 67 and 16. Be careful with your answers. Don't rush. So that would be 7 plus 6 is 13. 6 plus 1 is 7 and an 8. So that's 83. So if you want to represent it properly, you would basically say 1, 2, 3 in the base 8 is the same or is equal to, that's 83, not 183, is equal to 83 in the base 10 system. And obviously, this number I'd like to think is quite bigger than that number, although it has now 2 digits here. The fact that it's a base 10, I think it makes it bigger to the base 8. I'm not sure, but they're equal actually. So none is bigger than the other. They are both equal. Let's try another example, and then I'm gonna give you others to try, and then we can move on to the hexadecimal or hexadecimal to a decimal. So let's say you are given 1, 2, don't know, 3, 4, right? And you're asked to convert it to a base 10. So this would be you counting. So you start counting. You go 0, 1, 2, 3. So you have to have up to 8 to the power 3 times 1 plus 8 to the power 2 times 2 plus 8 to the power 3 times 1 plus 8 to the power 0 times 4. This, I think a to the power 3 times 1 is the same. I think I had it wrong. A to the, wasn't supposed to be the real root things here. So it's supposed to be 1 and 3. I'm not sure what a to the power 3 is. Is it 128? Let's say it was 128 plus 64 plus 24, I think, plus 4. Not sure if my calculations are correct. So you'd have 128 plus 64 plus 28. So 128 plus 64, 8 plus 4 is 11. And then 6 plus 2 is 8. We need 39 plus 28, 9. So 219 would be your answer. I'm not sure if my calculations were correct. But yeah, I'm also just a student, guys. I'm also just a student. I have to work on my 8 times table because it's quite bad. So convert 2,128 to a base 10. So everything that I'm gonna do now to a base 10. And then convert, let me see, 1111. Leave your answers in the comment section. And then we're gonna do corrections in there or on there. So let's talk about converting the hexadecimal. All these numbers are, of course, equal. It's just that the computer would basically have to convert everything to the numbers that it knows, right? So let's say you're converting 7a 3g 16 to a decimal. So what you do is you first have to write down all the answers, or let me think of a way to put it properly. So you have to write down all the things that you know are true. For example, 7 is equal to 7, but a, you know that a is equal to 10, right? And then you have 3, which is equals to 3. And then you know that D is equal to, I'm thinking 13. Let me see, A, B, C, D. So 10, 11, 12, 13 is 13. If you think of what the hexadecimal is, let's go back a little. Remember that hexadecimal means 10 digits, which means you have all the 7s, all the 8s and stuff, right? But once you get to 10, 11 up to 15, we use these alphabets, and you can only go up to 15. So you have to remember what A is, B is, and C, and etc. So obviously from here, what you do is the same step that we've been doing, where you go 16 to the power 0 times 13 plus, so 16 to the power 1 times 3, 16 to the power 2 times 10 plus 7 times 16 to the power 3, right? And then you calculate that, then your answer is basically that decimal. Don't know my calculations like that. Obviously have to work on them, but yeah. Okay, let's try an easy example rather than a very hard example. So what you do is let's say you have a B2 16 converted to decimal, your base 10. So this is the same as A. A is 10, you know that. B is 11 and 2 is 2, right? So you go 16 to the power 0 times 2 plus 16 to the power 1 times 11 plus 10 times, so 10 times 16 to the power 2. Right? 10 times 16 to the power 2. 16 to the power 2 is 256 times 10. That would be 256, 0. And then 16 times 11, because 16 to the power 1 is 16. So 16 times 11, that would be 167, plus 16 times 1 times 2 is 2. You go ahead and solve that, you get 168. Is it 168? Let me see. Oh no, this was supposed to be a 6 there. 168 plus 256, 0. Yeah, just don't mind that. That would be the same as 2728 base 10. And you basically have your answers. So try converting 7e 10 to the decimal, sorry, 7e 16 instead of 10 to the decimal 10. And then next time we're going to do things like other methods of solving certain things. For now, I'm just showing you the simpler way of doing this. Try this also. A, B, C, 16 to decimal 10 or base 10. Okay. So that's the end of the video. Please don't forget to subscribe, share the videos with people who might need the help. And yeah, that's it from me. It's gonna stop recording.